In this work, we explore efficient learning for 3D video understanding tasks using frame redundancy. 3D videos are mostly represented as consecutive point cloud frames, and current learning-based 3D video processing methods are all in frame-by-frame mechanism. Repeatedly processing them will introduce huge computation. For example, to process 5 frames of 80,000 points, a strong baseline MINC unit needs 5 multiplies 119 GFLOPS operations. To reduce redundant computation, we propose to take advantage of the geometrically close points between adjacent frames in a video clip. Because the semantic information of 3D Cloud is encoded in the geometrical structure of points, we naturally hypothesize that the geometrically close points must share similar high-level depth features. Our method, Efficient Video Engine (EVE), consists of a redundancy removing module and a residual learning module. Given a point cloud clip, the first frame x0 is processed by an encoder-decoder, getting features y0 for each point. For the rest frames x1, EVE matches it with previous frame x0, splitting x1 into x1 plus and x1 minus based on the matched pair's L2 distance. For x1 plus, EVE skips the computation and uses point features with corresponding index in y0. For x1 minus, EVE computes the residual features based on y0's results. And by combining the matched and unmatched parts, EVE outputs features y1 for each point in x1. Compared with MINC unit, EVE has a better performance computation balance. EVE achieves higher MIOU with similar computation, denoted as the red dotted line in the picture, and costs less GFLOPS, denoted as the green dotted line in the picture, with similar MIOU. And this video shows some qualitative results of EVE on the validation split.